Okay, so now we're going to look at angle, angle, side. And if you turn to page 284, you have the theorem. And it says, if two angles and a non-included side of one triangle are congruent to the corresponding angles and not included side of another triangle, then the triangles are congruent. Now the first example we're doing, and actually the only example in this one, is on 287. And we're going to look here at this. And it's given that angle P, I'm going to mark it to angle P is congruent to angle Z, and angle Q is congruent, and I'm going to mark it with 2, to angle X. Okay, so I have those. And I took care of that right there. So now it says compare YZ to, and which one would that go to on this other triangle? And I hope you all said OP using the distance formula. So we need to make sure that YZ is the same as OP. And then I would have angle, angle, side, okay? So Y is at -5, -4. Z is at -1, -2. And O is at 0, 0. That makes it nice. And P is at 2, -4. So distance, remember, is x minus x. So I'm going to do -5 minus -1. I'm finding the distance of YZ plus -4 minus -2 squared. So -5 plus 1 is -4, and -4 squared is 16. -4 plus 2 is -2, and -2 squared is 4, and that gives me the square root of 20. So now let me do OP. So OP would be 0 minus 2 squared plus 0 minus -4 squared. And I get -2 squared is 4, and 4 squared is 16, which gives me the square root of 20. So I have the angle side, and I know that these two triangles are congruent. And that in 6.2 is all there is. So now if you turn to page 295 in 6.3, we're going to talk about the HL triangle congruence. And the first thing it talks about here is there a side-side angle theorem? And that answer is no. Side-side angle. And see how it spells a bad word if you go that way? That's how you know that you cannot use it. We cannot use that to prove anything. But you can use this hypotenuse leg, and that's what the HL stands for is hypotenuse I misspelled it. Hypotenuse leg. So turn the page on 296, and it talks about it right here. And up here it says, remember, and maybe I ought to point this out, that the two sides that form the sides of the right angle are the legs. And see, it makes an L right there. Those are the legs. And opposite the right angle is the hypotenuse. So, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So let's look down at the example at the bottom of the page. And it says, determine whether there's enough information to prove that the triangles, these two triangles, are congruent. So we know that we have an angle, right? So we know we have an angle. We also know that we have a side, don't we? So right now we have a side and an angle. And what we need to do is prove that we have something else. We only have 2 out of the 3. Now, let's look at the hypotenuse. This is the hypotenuse of both of these triangles. So do you see that we know that they're congruent? So we have the hypotenuse, don't we? And we have a leg that is congruent. And so that's how I can tell that there is enough information to say that these two triangles are congruent. And that is all for videos tonight. We'll see you tomorrow.